Greetings and happy Global Accessibility Awareness Day. We put together this little tutorial on DIY assistive technology and the wonderful world of switch interfaces. So come along. A little bit about open assistive technology or DIY assistive tech. There are three main guiding principles. The first one is open source, which really comes from the software development end of things, where a coder would write some code and then open it out to the world so that anybody can take a look at it, remix it, and build on top of it without being very proprietary or controlling over the code. There's also crowdsourcing, where there's shared materials and shared cost of items, and the maker movement, which is all about making and putting things together. With the advent of 3D printers and low-cost components, the maker movement has really started taking off in classrooms and schools, and more maker spaces are being opened around the country. So the question is, why would you DIY assistive technology instead of just buying it? One of the main ideas is really around affordability and equity. So commercial products are expensive for a reason, because they do have a business model and they have a lot of overhead, and they have a smaller clientele of market. This chart is a little bit of like a comparison cost of what it would cost to buy something commercially versus what it costs to produce it and fabricate it in 3D printing. In all fairness, you do get with commercial items tech support and more durability, but sometimes the cost of something is really prohibitive for clients, and so DIY assistive tech is a great way to be able to provide access to somebody who may not be able to afford it. Another issue around commercial assistive tech is gatekeeping. There are a lot of people that are involved, especially in the medical models or school-based, if it's IP driven, to be able to get from when a user needs something until it's actually received. There's many people involved in the procurement process. And so assistive technology is a way to bypass some of that and provide an alternative way of getting access to assistive tech. It's also a low stress way of being able to access it, to test it out and see if it's ever even going to help or work before you invest money in a more expensive commercial product. Another great thing about the DIY assistive tech is the ability to really work with the user and customize it and meet their functional and aesthetic needs, which is a little bit more difficult to do with commercial products. And so it's really working with the user and co-designing and creating a great match between what the user needs and also making it look very lovely and nice. So you can actually build very many things. These are some examples. You can build a switch interface, which we'll go into a little bit more, and also a wide variety of switches. The picture on the top shows something that's a light switch, and so it just detects a change in light and then activates, while the one on the bottom is more of a mechanical switch, so you actually need to press it and it sends a signal. People with physical disabilities that cannot normally access devices, computers, the way that they're commercially designed, will use switches that they are able to access to interact with all these different types of devices. So now, why would you need a switch interface? It seems that most switches have this little mono jack cable that you should just be able to plug into the... But a computer doesn't really know what to do with this switch, and so you need this lovely little thing called the switch interface, which is exactly that. It's an interface between the switch and the computer, and it lets the computer know what the switch is trying to do. So interfaces, how do they work? Let's take a look at one. All right, so this is an example of the Enable Controller Mini, and it's made by the wonderful engineers at Makers Making Change. And so it's got a USB cable that's connected to the computer, and then this particular model comes with 4 ports, and you can attach any kind of switch that you want into it, and then connect it. This particular model also comes with an analog one, so you could attach a joystick if you need to. And inside there's a microcontroller board that sends code. All right, and so how does this magical thing all work? There's something called the IPO process, and it includes the input, and so that would be either a button press or some type of sensor change, and then the process, which is what the computer or the microcontroller, also known as an MCU, processes the code that is placed on it, and then there's an output, so it'll activate or do something on the host computer or mobile device. And all of this uses something called HID, which stands for Human Interface Device. The HID is a library, and library is an additional piece of code that gets added to the base program, and it sends information like key presses, keyboard presses, mouse emulation, so the location of a mouse on the screen, gamepads, so button A, button B, up arrow, down arrow, or media controls like play, pause, skip, next song. There's some beginner friendly options on how you can kind of create this interface with a computer. There's some friendly boards like the Makey, the Microbit. Version 2 now has a lovely Bluetooth extension made by Bill Seaver, and also Adafruit boards like the Circuit Playground Express and the GEMMO M0. The wonderful thing about these boards is that they are alligator clip friendly, so if you don't have soldering skills, you could just kind of like clip these little clips on and then create circuits based out of any kind of materials. Makey has wonderful resources on how to build switches that connect to it. These boards can be programmed by this lovely platform called MakeCode, made by Microsoft, and this is block-based coding. And so this little animation here will show you how simple it is to create an input. And in this example, you just touch one of the pins, and then you turn it into a mouse click. So you just made a program, and then you just click and drag it into the board. Another way to code these boards would be through CircuitPython, developed by Adafruit, and it's a flavor of MicroPython. It's text-based, so it's a little bit more difficult, but there are some great tutorials on how to do it and step-by-step explainers. So Python is a pretty user-friendly beginner language to code in. More advanced options will include boards by Adafruit, where there are more pins and more options. Also, you can build them with Raspberry Pi Zeros or the Picos that recently came out. And the industry standards are the Arduino boards. These are usually programmed using Arduino, the IDE, Integrated Development Environment, or also CircuitPython or MicroPython, depending on the board. So the question is, how do you get one? Well, if you have a maker friend, there's some very handy repositories out there. Adafruit Learn, the link is down at the bottom, has some wonderful tutorials, step-by-step instructions on how to build a wide range of these devices. You can filter through keywords like keyboard or gamepad to kind of get an idea of how you do it. And after you take a look at some, you'll kind of notice that there is a pattern to how these are made. Another great resource is the AT Makers website, led by Bill Bilko. He's got some great projects out there and also instructions on how to build it. And the Makers Making Change Assistive Device library has instructions on how to build almost very many switches and switch interfaces, and the instructions are very user friendly, and it also comes with like a bill of materials, so you kind of know ahead of time what you're going to need to build and make devices. But what if you don't have a maker friend? You can request it. On the Makers Making Change website, if you find an item that is what you need, there's this handy little button, the request button right there. And it starts you on the request process that kind of looks a little bit like this. You indicate that you need a device. A maker on the website will indicate that they can make it. They'll discuss it and discuss details with you, build it for you, send it on for delivery. You are responsible for reimbursing only for the cost of the materials, and the maker volunteers their time and expertise and then sends it out to be delivered. All right, so that was a super quick overview on DIY assistive technology and switch interfaces, and how you can use switches to access computers, mobile devices, and then some. So I hope you have a wonderful Global Accessibility Awareness Day, and looking forward to seeing you again next year.